Hey guys, welcome to UAS 1500. This is the course that's all about components and tools and maintenance and documenting, diagramming, all that kind of fun stuff. And it actually came about because of a lot of feedback from industry saying, hey, will you guys make something like this so that students are introduced to this stuff? So learning goals for the course itself. For this lecture specifically, I want you guys to understand the course as a whole, be introduced to different types of quads, or history of quads is a better way to put it, and from the experiences that I've had, and then understand the course expectations. And the whole purpose is, if you can have this background, it'll help you navigate through the course and help you understand the purpose of the course and kind of take control of your own learning. So for anybody who hasn't met me yet, my name is Shaylin Drake, and it is myself and Duke Papworth that typically teach this course. Duke teaches it up in Logan, and I teach it everywhere else. I'm going to drop this into the description for this video, but there are quite a few career opportunities in drones, as you guys probably already know if you're in this course, but not all of them have to do necessarily with building drones, but they do all have to do with troubleshooting and documenting and understanding how a drone works to be able to do a job properly. So a few of those career options, obviously we've got delivery pilots, and that's going to be huge over the next decade or so here. Mosquito abatement is majorly picked up. I would say about a third of the mosquito abatement organizations throughout the state of Utah use drone pilots, and of that, probably 80% use our students. Construction, doing mapping and surveying, stockpile reports, public services, you've got your real estate, your videography, DOT, inspections, ranching, security. Pretty much anything today now uses a drone or can use a drone for efficiency. So, like I said, my name is Shaylin Drake. I used to teach up in Davis County. I taught high school for almost 15 years. A huge variety of classes: English, Read 180, Concurrent Enrollment English, AP English, Yearbook, Study Skills, and drones up in the Davis County area. And then I got hired at Utah State University in August of 2022. I teach on the Price campus and pretty much teach all things drones. I am also a glider pilot. Then I also have a little bit of a history in this whole kind of arena. You guys might be wondering how on earth an English teacher became a drones professor. So actually, around 2004, I started building and flying RC airplanes. Turns out those are actually drones, okay? And each one of these guys, except for Josh, has been building and flying with me for about 20 years. Every single one of them started their drone career with building RC airplanes, and now have an entire professional persona based off of building and flying drones and testing them and being part of the actual industry. So I have kind of dug into a little bit of the history of drones, and normally when I say the word drone, I'm talking about anything that is controlled remotely, okay, and flies. And for the purposes of this presentation and this class, we'll probably focus on the word drone being a multi-rotor of some kind. Really the first one, or the first flying thing that had multiple rotors, was in 1923. So 100 years ago, at least, more than 100 years ago. And the technology, the idea, the design has been there for that long. But I do remember around 2010, actually no, it was earlier than that, when Drone Jesus from the previous slide, he brought out this thing, and at the time we were all looking at it going, okay, this looks funny, but it was a hexacopter, and it was huge, way bigger than the DJI Matrice. And John had 10-pound dumbbell weights that he had brought out with this thing, and he was test flying it. He had been subcontracted from BYU to make a drone, a hexacopter with camera equipment on it, and the camera equipment was ridiculously heavy. And that was my first experience with something that we would consider now to be a drone or a multi-rotor. And then I remember my uncle bought one of the very first DJI Phantoms. January 7th, 2013 was the push out date. There were a few around right before that, but My uncle brought one to a family party one time, and again, just the weirdest looking thing ever. But then I have to fast forward not very many years, okay? Fixed wing and VTOL drones started to come about, fixed wing and VTOL multi-rotors. And even FPV racing has been around for over a decade now. It's kind of frustrating that we're not farther along than we are now with this technology here in the United States, but obviously it's growing exponentially. Quadcopters, multi-rotors, VTOLs, fastest growing industry in the world in building, designing, and usage. So as part of that, we've seen 8K cameras. We've got 3-axis or even more now gimbals. We have thermal and IR, and that has come down in price like crazy. We have multispectral imaging, LiDAR, RTK, and PPK, and interchangeable payloads, so things that you can move around. And if you don't know what some of those things are, I would really strongly suggest clicking pause and looking into them, because you'll geek out. It's kind of fun. We've got all kinds of airframes that we use, foldable airframes, carbon fiber, 3D printed, which I'm not a huge fan of yet because they still break really easily. Fixed wing, VTOL, all different kinds of battery casings, all the way up to 720 degrees of obstacle avoidance, terrain following, tons and tons of features on these drones. The next two leaps that we have to make as an industry is, number one, battery life, okay? But number two, coming down in price, because all of this is ridiculously expensive. We are seeing a lot of proprietary software out there for mission planning, 3D modeling, for the controllers or the transmitters that you hold in your hand, for the batteries, the payloads, and definitely maintenance. You typically can't fix your own drone if you've got like a DJI or something. Sometimes you can, but a lot of the time you have to send it back to the factories. And then we are seeing a bit of growth in the open source arena. There's a lot of troubleshooting to it, though, because there's no textbook on, hey, this is what you do. It is a growing part of the industry, and you've got some things that we'll kind of go over towards the very end of this course that talk about an autonomous drone versus a freestyle drone versus a racing drone, and when you would need what type of software. Lots and lots of online reading, lots and lots of troubleshooting. And then the fixed wing arena is also growing like crazy. They typically are where the higher paying jobs are, okay? Being able to fly, maintain, manage, all that kind of stuff, a fixed wing drone. And manual flight skills, even though a lot of the drones take off and perform autonomous missions, manual flight skills are vital. It opens up huge possibilities for what you can do with the drone. And obviously we've got our air taxis that are coming this way. I'm going to drop this into the description for the video as well, and it kind of goes over a little bit more of the history. So our program here at USU is all about an introduction to all things drones, which is really good industry feedback that we've been getting. And we want to help you guys find where you want to focus. We want to give you opportunities. Soft skills are huge. Time management, communication, professionalism. Okay. We also think it's really important to include hands-on experiences. And then obviously our end goal is to help you guys get a job. So this is the textbook that is required for this class, the Droner's Manual. As of 2025, you need the second edition. We'll pay attention to when a new edition comes out and update. You will need it, like 100%. You cannot pass this class without it, kind of thing. Okay. You will have quizzes based on the textbook and the lectures that I record, and you'll be able to follow right along on those things. The textbook is, we'll call it dense. Okay, it does get into some very technical stuff, but I try to keep the content that we go over in this class more of an introductory style. You guys will also need a flight test chuck glider. These are foam board. You will be using hot glue to put them together. Typically, they come in a 2-pack or higher. That means up to 50 or whatever. My suggestion is to get with someone over Canvas email and say, hey, you want to go in on a pack? And you guys can each pay $10 instead of doing 25 for 2 of them. You will also need a quadcopter. Here are your 2 options. You do need to plan ahead on purchasing those. They probably really only take, I don't know, maybe 2 hours to put together at the most. But if you save it till the day it's due, you likely won't have 2 hours to put it together successfully. Now, this is a modules-based course, meaning that if you just use calendar or just use assignments, you'll never understand what's going on. Okay, you have to use the entire module. There is always a module overview page where you will find a schedule, some tips, some links, and things like that. It'll have weekly plans scheduled out in it. Obviously, log in often, and again, just try to stay away from the whole assignments and calendar thing unless you use those tools to supplement modules. Otherwise, you need to really dig into those modules. This is my contact information. So email address, I am in the West Instructional Building in 102 in Price. Happy to answer any questions for you guys. You will come across 3 or 4 assignments that will have a lab component to them. And we'll talk about what those lab components are here in a little bit. Individual learning goals are a huge part of taking responsibility for your own learning. It helps you to kind of direct yourself. Definitely, like I've said, read the textbook, review the slides, watch the videos, all that fun stuff. Your number one goal is just to gain an understanding of drone components, tools, building techniques, and systems, and then to have some fun. Those are all huge parts of the class, but making sure that you get the gist of the guts and the tools is probably. Make sure you pay attention to what the syllabus says. Like I said, there are 3 or 4 assignments that you could potentially have to come into the class to complete, just depending on what kind of access you have. There's one assignment in particular that will be really hard to do on your own. Late work is docked 10%, but just turn it in, okay? We'll take it until the last second. I will anyway. I'll take it till the last second. Droner's Manual 2nd edition is required. Chuck Glider and a quad build are required, and they are linked in the syllabus. The bulk of the class is progress checks. That's the biggest percentage of your grade. Quizzes, briefings, and assignments. And pay attention to the syllabus. I know it's hard to read through the whole thing, but it definitely goes over what the expectations and requirements are. And then focus on your modules.